So far in CO3, we have completed the welded joints and bolted joints. From this lecture, we are going to discuss about the design of riveted joints. So in general, we can classify the joints into two types. One is permanent joint and another one is temporary joint. In permanent joint, we have already discussed the welded joints, and in temporary joints, we have already designed the bolts. So now we are going to design the riveted joint that comes under the permanent type of joint. So we cannot remove the joint. So this is the construction of a rivet. So it has a head, a shank, and a tail. Okay. So the shank is a circular section and it is inserted in the plates, and the tail is a tapered section. Okay. So when it is inserted on the two plates, then the load is applied on the tail, and the tail clips the two plates together. Okay. Then the rivets are specified by its shank diameter. For example, if the shank diameter is 20 mm, then the rivet is specified by 20 mm rivet. Okay. So in general, the rivets are used in pressure vessels and olden days pressure vessels and some light loaded joints, because nowadays they are using welding for pressure vessels. So in the ancient days for boiler shells and pressure vessels, they have used rivets for joint. So the method of riveting. So this is the initial stage of rivet. So this is the head, this is the shank, and this is the two plates. So that we want to held together, and this is the tail portion. Okay. So the force is applied on the tail by using a die, and the tail portion is compressed, and it will form a head-like structure, so that it will clip the two plates together. Okay. So this is the process of riveting. So this is for small kind of riveting. In case of heavy loads, then we can apply a heavy amount of force on the opposite side. Okay. So this is the process of riveting. So these are all the different types of rivet heads. So the first one is snap head. So we have a circular head. Then the next one is pan head. So uh, the top surface is a flat one. Then we have a mushroom head. So here also it is circular, but the diameter is high. Then we have a countersunk head. Then we have flat head, and we have round countered sunk head. So in mostly we are preferring snap head, since it is very simple in construction. So there are two types of rivet joints are there. So in the previous slide we have seen different types of rivet heads. Here it is types of rivet joints. So the first one is lap joints. So just like the welding, two plates are held together one by one, and the rivet is placed at the center. Okay. So this is lap joint. In case of butt joint, the two plates are held like this, and a cover plate is used. Okay. And the rivet is carried out like this. So the cover plate is used to support the two plates. Okay. So in case if you are using single cover plate, then it is single cover joint. For heavy loader application, we can use two cover plates. Okay. So this is butt joint. So in this EO, we are going to design the rivet for lap joint and butt joint. So there are four important terms are used in rivet joint. The first one is pitch. So the pitch is the distance between two adjacent rivets. Okay, so for example, this is rivet number 1, 2, 3, and this is another row. It is 4 and 5. So pitch is the distance between two adjacent rivets. Then row pitch means it is the distance between two rows of a rivet. So this is row number 1 and this is row number 2. So row pitch means it is the distance between two rows. Then diagonal pitch means in some cases you may have a zigzag type of rivet. So zigzag means the rivet will be like this. So here you can see that. So it's a zigzag type of rivet. So in that case, the diagonal distance between two rivets is called as diagonal pitch. The last one is margin. So margin is the distance between the side of the plate and the axis of the rivet. So here this is the margin, and for the rivet 3, and this will be the margin. So this is the margin for rivet number 3. Okay. So these four terms are used in rivets, and while designing the rivet we have to calculate all these four terms. So the type of rivet joints, so first one is single riveted lap joint. So we have two major classification, one is lap joint and the butt joint, and in the lap joint we have three classification. The first one is single riveted lap joint. So in this we have a single row of rivet. So it's a lap joint, but only single row of rivet is used here. In case of double riveted joint, we have two rows of rivets. Okay, so this is row number 1. For example, in the first row we have 3 rivets, and in the second row we have another 3 rivets. So this is rivet number 1, 2, 3 in the first row, and 4, 5 and 6 in the second row. Further, the double riveted lap joint is split into two. First one is chain type. So this is chain type. So here the two rivets are like a chain structure. In the case of zigzag joint, then it will be like a Z. Okay, so this is a double riveted lap joint with zigzag riveting. So this is double riveted joint with chain riveting. This is zigzag riveting. Okay, fine. So in the case of lap joint, the pitch is 3 times the diameter of the rivet. Okay, so in design of rivet joints, once after calculating the diameter of the rivet, then the remaining are the empirical relationship. You can use the diameter for calculating pitch. So here the pitch is 3 times the diameter, and the margin is 1.5 times the diameter of the rivet. Then the transverse pitch or the row pitch. So transverse pitch is famously like the row pitch. So the row pitch is 0.8 times the pitch for chain riveting, and it is 0.6 times the pitch for zigzag riveting. Okay. So this is a single riveted lap joint and double riveted lap joint. In lap joint, we have two type of stresses. The first one is when a tensile load is applied on the plate, then the rivet is subjected to a direct shear. So just like the threaded fasteners, it is subjected to direct shear at this location. Also, because of the thickness of the plate, it is subjected to a very small amount of bending moment. Okay. So for example, if the load acts here, then we have a small distance here. So when it rotates, it will try to bend the rivet like this. So obviously direct shear will be maximum, but a small amount of bending moment will be there. Okay. So this bending moment causes distortion of the plates. You can see the plate structure once the bending is applied. So distortion happens. So this is the main drawback of using the lap joint. So that is why people are preferring butt joints. So these are all the types of butt joint. So first one is it is single riveted butt joint, these two images. So here a single cover plate is used. So in case a single cover plate is used, and this is the left side plate, this is the right side plate. So in the left side we have a single row, and in the right side we have another single row. Okay, for example, so this is left side plate, this is right side plate, and this is the cover plate that connects the two plates together. So one row in the left side, one row in the right side. So this is single strap butt joint. In case of double strap, we have single rivet, but two cover plates are there. One in the upper side and one in the lower side. Okay. So this is the types of single riveted butt joint. This is single strap, and the next one is double strap. Then in case of double riveted butt joint, we have double strap here. You can see that two row in left side plate and two rows of rivet in the right side plate. Okay. So here in all the butt joints, the pitch is 1.5 times the margin is 1.5 times the diameter of the pitch. Diameter of the rivet. So in case of double riveted and double strap, we have two rows and two cover plates. Also we have a chain structure. So this is a chain structure, and here it is a zigzag structure. Okay. So in chain pattern, the rivets are formed like a chain, and in zigzag it will be in Z direction. It will be like a Z. Okay. So these are all types of butt joints. So remember that in lap joint we don't need to use any strap plate, but in butt joint we have to use strap plate. So either you can go for single strap or you can go for double strap. So the theories of failure of riveted joints. So the possibility of failure. So the first one is shear failure of rivet. So in most of the cases, the rivets are subjected to shear failure, and that too it is direct shear. So you can see the first image. So the tensile loads are applied. When the loads are applied on the rivet, then this will shear this region. So this is the possibility, the reason for direct shear. Then the second one is tensile failure of the plate between two consecutive rivets. So this is the structure. Two rivets are formed like this. So when the tensile load is applied here, then there is a possibility of plate failure in this region. So it is not rivet failure, it is plate failure. Okay. So that is the second possibility of failure. The third one is crushing failure on the plate. So a single rivet is formed when the tensile load is applied. So this rivet will crush this region. Okay. So this rivet will crush this region. So a crushing stress is developed in this region. So because of the crushing stress, crushing failure may happen on the plate. So that is the third possibility of failure. And the fourth one is shear failure of the plate. So here, because of this rivet, when the load is applied, there is a possibility for direct shear in the plates like this. So the plate may crack in this direction. So that is the fourth possibility. Shear failure in the plate in the margin area. The last one is tearing of the plate in the margin area. So when the load is applied, there is a possibility for tearing of the plate like this. So the plate will open like this. So that is tearing. So there is a possibility for tearing of the plate in the margin area. That is the fifth possibility. So among these five, the first one is the most common one. So that is shear failure of the rivet. Okay. So when you are focusing on the design of rivets, you have to be very careful about the amount of shear acts on the riveted joints. So we'll see the relations for failures, equations for failures. So first we'll start with the shear failure. So as I discussed earlier, when the loads are applied, then this region is subjected to direct shear. So in the case of lap joint, a single direct shear will be there. In the case of double strapped butt joint, you have 1 and 2, 3 and 4. You have 4 regions of failures are there. Okay, fine. So the stress equation is, we know that the load is equal to area into stress. So the load is PS, that is equal to area is pi by 4 d square. Here d is the diameter of the rivet and tau is the permissible stress of the rivet material in shear. In case of double or triple riveted joints, so if for example if two rivets are formed like this, then you have to multiply 2. So this n depends on the number of failure areas. So here it is 1, 2, 3 and 4. So you have to multiply 4. It depends on the number of rivets and the number of failure regions. So this is the shear failure. And the tensile strength of plate between two rivets. So the second possibility of failure is failure of the plate in this region when the tensile load is applied. So in between these two rivets, there may be a possibility for plate failure. So the load is P is equal to area into, since it is tensile, then the stress is sigma T. So the tensile load is equal to, here area is the length into thickness of the plate. So here the thickness is T. So the length is pitch minus diameter, because here you have radius and here you have another radius of rivet. So 2 times the radius will give you the diameter of the rivet. So it is P minus D into T into sigma T. So here PT is the tensile load applied, then P is the row pitch, then T is the thickness of the plate, sigma T is the permissible tensile stress of the plate material. So the third one is crushing failure of the plate. So this region is subjected to crushing stress. So the equation is PC is equal to, so the area is D into T. So this is the diameter of the rivet and T is the thickness. So area is D into T. Then it is, since it is crushing stress, then sigma C, and N is the number of rivets. So here PC is the load, D is the diameter of the rivet, T is the thickness of the rivet, sigma C is the permissible compressive stress of the plate material, and N is the number of rivets. Okay, so these three stresses are very important. The remaining last two types of failure we can neglect it while designing the rivet, but we have to be very careful about these three type of failure, that is shear failure, tensile failure of the plate, then crushing strength of the plate. Okay, so all these equations are available in the data book. So in the next lecture we will see the design procedure of riveted joints and the relations for calculating the dimensions of the rivet joints in detail along with the problem.